Hi guys, what I have to show you are three different instances of Eclipse, and I'm running three programs corresponding to the diagram for a proxy server that I shall be showing you in the presentations this week. So on the left hand side I've got first instantiation of Eclipse, and I'm running it, using it to run TCP echo client. And the thing I want you to notice is that I'm actually connecting to communicate with another system whose IP address is 127.0.0.1, port 100. And the second program I'm running, by means of a different incarnation of Eclipse, is the simple proxy server. And I want you to notice, if I go to run configurations, it'll tell you which two parameters it will be using when it starts running. So just do that again, run configurations, and go to arguments. So it's actually running on a machine with IP address 127.0.0.1, and it's going to form a connection with a remote machine running on this address, which is listening on port 99. And if a client wants to use the services of simple proxy client, it can do so by forming a session on port 100. So I'm not going to run that yet. I'll just tell you what the third program I'm going to run is in a moment. So I'm going to close that, and going back to this, well, TCP echo client is actually going to form a collection with a system running on this IP address at port 100. Well, this proxy server will be listening on port 100. And it's going to connect to a machine on port 99. So let's see. Let's have a look at the echo server. The echo server, again, I'm about to run this on a separate instance of Eclipse. It's actually going to, if I can make this cursor move, it's actually going to create a server socket on port 99. So just to repeat, the proxy server will establish a connection with this machine on port 99, and the system over here is creating a server socket to deal with any incoming requests for a connection. So what I'm going to do is, first of all, to run this program. I'm going to run it, and you'll notice there's a little message here saying echo server blah 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 is running. And I need to do that because the proxy server cannot connect to a server that's not running. An exception would be thrown. But now that it's running, I can actually run the proxy server. And this is what happens. So it started the proxy for IP address port 99, and it's actually connected to this system over here, which is the echo server, and this system is available for me to communicate with on its port 100. So all that remains to do to get a demonstration of these three concurrent programs is to run the client. So I'm going to do that, and you'll see that not very much happens, but it's alive because it tells me that TC Echo client is actually started. So what I can do, what my intention to do is to type something at the keyboard into the client. Then the client is actually going to transmit the message to the proxy server, and the proxy server is actually going to relay the message, whatever I type in at the keyboard, to the Echo server. And what the Echo server is going to do, if you have a look at its specification, it's a program I've shown you before. In fact, it's a program that we've analysed in some detail before as part of all our work on threads and internet programming. What the Echo server is going to do is simply to echo the message received back on its port 99 back to the proxy server. And what the proxy server is going to do when it receives the message is to simply send them in this chunk of code here. I mean, I can't actually show it in its entirety. It's going to send the data back to the client, send the message received from the Echo server back to the client. And what the Echo client is going to do is simply to tell me when that message has been received. So from a functional point of view, the Echo server is fairly trivial. All it's doing is going to receive a string, it's going to receive a sentence, in a text-based sentence, and it's just going to capitalize it, turn it into uppercase letters, and then send it back. And what the Echo client is going to do, and I'll just show you this very, very quickly. I've enabled it to repeatedly send messages from the keyboard. So while true, I'm going to read a line from my keyboard and then send it on to the proxy. So I'm going to be able to do that repeatedly. And a small modification I've made to the Echo server is that it's repeatedly going to be prepared to receive a sentence from a client in the form of a proxy, the proxy server, and then send it back to the client, which in fact it turns out is the proxy. The proxy is like the go-between the client and the server. So we'll put it to the test. Simply say, I'm simply going to say, I'm going to welcome a proxy server, and the welcome is from the IFG students on the CS 2021 course. And let's see if it works. I'm just going to press return. I've just typed that message in my keyboard, and immediately the message comes back from the server. Welcome. It should be just welcome from the IFG students on the CS 2021 course. And I want to think very carefully about what functionality a proxy server could have, and I want you to think about from a communications point of view exactly what it does do. And the question I'm going to ask you is, does it actually offer concurrent communications? I mean, if, for example, the server, instead of waiting to receive a message from the client over here, supposing it wanted to pass on a message from the server to the client. I mean, maybe it's just going to identify itself like this is an echo server, and I'm on a particular port with a particular IP address of so and so. Please enter some sentence at the keyboard and send it to me. Question is, or is it something slightly different? Is the proxy server such that if I send it a message, it's going to send a message to the server, and not until this server decides to send a message back will a communication link in this direction that I've just shown you, that watch the cursor, in this direction, that will be inactive. On the other hand, you might want to think, well, it would be very nice if the proxy server could handle concurrent communications in these two directions. In other words, if the program I'm running here is capable of generating lots of messages, maybe theoretically it's possible for the server to send an answer to each one of those messages, and so there may well be concurrent two-directional communications within the proxy server. It's something for you to think about, and maybe you'd like to have a look at this code in the relevant part to see whether it does in fact offer concurrent communications. And the reason I'm asking this question is this. I mean, maybe if I replaced the Echo client by a browser, and its instruction is to send the message, the HTTP message, which we're going to or will have discussed already today. The HTTP message, get a particular web page. If I send that to the Echo server, forget this. The Echo server might not be this Echo server. It might be the BBC's web server, and this web server could, in principle, send a web page back to me. And providing I'm prepared to do it, I could display it at the same time that I'm actually sending more HTTP requests to this web server over here. So it's just a possibility. Anyway, I'm going to finish that point, and what I intend to do is to give you these three programs. And what you've got to do is to make sure that they are executed with this communication in mind. I want this client to communicate with the proxy, and I want the proxy to communicate with the server, and I want the server to send data back to the proxy, and the proxy server will send data back to the client. So you've got a sort of a loop communications, and I want you to think a little bit about the possibilities of that communication. I mean, what are its characteristics? The other question is, well, at the moment this is just playing the role of a relay station. What other functions might the proxy server have? I mean, it could store or make a record of all the data received from the Echo server and put it in its local database. Or maybe the proxy server is playing the role of a cache, a web cache. In other words, if a browser, supposing this is a browser, if the browser requests a web page from a remote server, maybe 18,000 miles away, first of all, it's going to look inside its store whether or not it has a copy of what's being requested. If it does, it's going to very rapidly send it back to the requester. On the other hand, maybe this cache memory has got to perform various checks. For example, is the page absolutely bang up to date? And if the cache isn't quite sure whether the data's up to date, it can actually, presumably, send a query to the remote server saying, is the date of this document your current version? And if it's not, then the server will actually load the data that's actually out of date onto the proxy server, so that when other clients actually request the same page, it's going to gain the benefit of the speed of having the document stored locally. Maybe just up the road, rather than the other side of continental United States. So anyway, I hope I've given you a few things to think about, and if you have any questions now, just fire away. But thank you for listening.